All right, on this one, it says, what is the value of f plus g of -1? So this one just says, okay, take my f and g, add them together. So my f equation is 3x squared minus 2 plus 4x plus 2. I can go ahead and simplify this now if I want, or I can go ahead and plug in a -1. I know that my -2 and my +2, don't those just cancel each other out? So really I have this. And now what do they want me to do? Plug -1 in. So 3 times -1 squared plus 4 times -1. Now, if you put this in your calculator to check your answer, if you don't put parentheses around this -1, it's going to give you the wrong answer. Because -1 squared is a +1, so that's 3 minus 4. So my answer is -1. Okay, how many of you got the right answer? Okay. If you messed up, it's probably that -1 that got you. Okay, make sure it's -1 quantity squared. Okay, next one. If f of x equals x squared plus minus 1 and g of x equals x minus 1, which expression is equivalent to f divided by g? So this says, okay, put my f equation on top and my g equation on bottom, and then I have to simplify. Okay, can I start canceling out my x's and my 1's? Can I? That's like saying 3 minus 2 is 1 minus 2, cancel out my 2's. Remember, we can't do that. Okay, but I can do what to the top? Well, x squared minus 1 factor. This is the difference of squares. So look, this will factor as that. So you have to factor anything that can be factored first. This was the difference of squares. So now what's going to cancel? My x minus 1's and x plus 1 is my answer. Huh? Well, when you cancel something out, they have to look exactly alike. Okay? So I have x plus 1 left. So you cannot, remember, you cannot start canceling things if there's a minus or a plus sign in between, only if it's multiplication. Okay. All right, next one. Okay, I like this problem because they make it look really confusing, but this is actually a really easy problem. Okay? It says if f of x is this equation and g of x equals -2, which graph corresponds to the function f times g? And that f times g of x, okay, they're just saying that they each have f of x times g of x. They just didn't want to write it twice, so that really doesn't mean anything. So first of all, they want me to say my f equation times my g equation. All right? So when I simplify that, -2 times x is -2x. What's -1/2 times -2? Plus 1. So then what they want me to do is they want me to graph this and see which one of these lines matches up. Okay, so that was pretty easy. Multiply the two equations together, graph it, see which one matches up. Can you tell without looking in your calculator which of these lines is going to represent this equation? It's going to cross the y-axis at 1 and it has a negative slope. So it has to be this line. You cannot, if you put it in your calculator to graph, it would have to be this equation. Or this times this in your y equals? Yes. So James said, could I have put x minus 1/2 times -2 in my calculator in my y equals and graphed it? Yes. Okay, I'm going to show you what that looks like just in case you've forgotten. I hit my y equals. I'm going to clear anything out that's in there. So parenthesis, -1/2, so I'm going to put -0.5. What was it? X? Oh, wait. It was x minus 1/2 times -2. So if you put just that in your calculator and graph it, it will give you the line that you're looking for. Okay? Any questions about that one? Okay, next. All right, if f of x is 2x plus 5, g of x is 3x, what is the value of f of g of 1? This is not a multiplication problem. This is the composition of the two functions. We just did this last chapter. So they're wanting this, f of g of 1. Okay, would remember how we did that? We said, okay, we're going to write down the f. Then we're going to go to our g equation. And what are we plugging in? We're plugging in, but instead of 3x, what are we putting in our x? A 1. So when I plug in 1 here, 3 times 1, what do I get? 3. So I keep my f. I go to my g equation, and I'm plugging 1 in to get an answer. Now, this says go to my f equation, and what am I plugging in? 3, right? 2 times 3 plus 5, 6 plus 5, 11. Okay, we did those the last chapter. Always do what's on the inside first. So I would do find g of 1 first, find that answer, and plug it into my f. Okay, let's do another one. This one's just like this one. Which expression represents f of g of x? So here's how we've always done it. We write down our f. And instead of g of x, I'm going to write down what g of x is. G of x is 3x squared minus 1. Now this tells me go to my f equation, and in place of this x, I'm putting this entire thing. So I have 2 times x, the x is 3x squared minus 1, plus 7. Distribute your 2. 6x squared minus 2 plus 7. 6x squared plus 5. So you guys remember doing those? It's exactly like what we did in the last chapter. Okay, this problem is a little different, and it looks kind of confusing at first. Okay, they say if f of g of x equals 2x minus 1, how might f and g be defined? So here's what they're saying. They already found this answer. They did it. Okay, they're saying f of g of x is 2x minus 1. So we have to figure out which of these did they use for my f and g. So really the only way to work this problem is to take each one, find the composition, and see which one gives us this answer. Okay, so let's start off. Where do you want to start? A, B, C, or D? Okay, we'll start with C. All right, so if I'm finding f of g of x, I would write down my f, and instead of g of x, I'm writing down what g of x is, x minus 1. Now I'm going to go to my f equation, which is right here, and in place of this x, I'm putting x minus 1. So I have 2 times x minus 1 minus 1. So I get 2x minus 2 minus 1. So I get 2x minus 3. Is that what I want? No, but I'm really, really close. Which one do you think I should do instead? What's the only difference? And instead of the x minus 1 right here, if I had an x plus 1, would that work? So if this was an x plus 1, which, it's actually d. Okay, let me work d out and show you why. Okay, I'm finding f of g of x. So that means take my f equation, or write down my f. Now I'm going to write down my g equation, x minus 1. Now this tells me to go to my f equation in place of this x. I'm plugging in x minus 1. So I have 2 times x minus 1 plus 1. Distribute 2x minus 2 plus 1. 2x minus 1 is my answer. Is that what I'm supposed to get as my answer? Yeah. Okay. There's not a shortcut for that one. There's no way to make it easier. You just have to play around with the answers. Okay. That one is kind of time consuming. Yep. Nope. All right. Next. Go back real quick. All right, so while he's copying this one down, I want everyone to look at the next one. Which statement is true for the function 1 over x plus 4? So if it's talking about domain and range, what should you probably do? Graph it. So I want everyone to graph it. And then we're going to talk about our choices. 1 divided by. Now, when you put this in your calculator, it's very, very important that when you put the denominator in, if you don't use your fraction button, that denominator is in parentheses. Okay? If you don't put 1 over and then parentheses around your denominator, you're going to get the wrong graph. Or you can use your fraction button and do it that way. Okay? Now I'm going to graph this. All right, there's the graph. Okay, let's look at our choices. Choice A says 4 is not in the range of the function. So if I just told you, what is the domain of this function? Domain means my x values. So usually my domain would be negative infinity to infinity. Is this one from negative infinity to infinity? No. What does it not include? It doesn't include, there's like this vertical asymptote right there. There's no values at x equals negative 4. So does my domain include negative 4? No, it doesn't. Okay, so let's look at our choices. Our choices says 4 is not in the range. 4 is not in the domain. Negative 4 is not in the range. Negative 4 is not in the domain. Well, which one is it? It's D. So whenever I have a break in my graph, because 1, 2, 3, 4, I have this vertical asymptote right here. There's a break, so that means that cannot be in the domain. Okay? Your graphing calculator won't actually show the vertical asymptote, but it shows where the graph goes. An asymptote is where there's a break in the graph, and when you look at a picture of the graph, it never crosses that vertical line. So there's this imaginary vertical line right here at negative 4. See how the graph goes down and then it goes up? It doesn't ever cross that space. That's where a vertical asymptote is. And the shortcut to find your vertical asymptotes, set the denominator equal to 0 and solve. Okay, that will show you where your vertical asymptotes are, and that's also where the domain does not happen. It does not exist at vertical asymptotes. Okay, so let's do one more problem. The next one, this is the last one for the day. What is the domain of the function? So I want you to graph this and tell me what is the domain. So again, either use your fraction button or put the top in parentheses, bottom in parentheses. It's very important that you do that. So when I look at this graph, I have vertical asymptotes where? I have it at 2 and at -4. Okay, and if you can't really tell by looking, look at your choices and it kind of tells you. But I have two places where my graph has a break. Okay, that means x cannot equal 2 and -4. And the same thing, if I set that denominator equal to 0 and solve, when I factor this, I get x equals 2, x equals -4. That's where my domain could not exist. I have vertical asymptotes there. So my answer is D.